Hello, my dear student. In this lecture, you will learn how to solve a problem based on chi-square test. Chi-square test is one of the most important method in statistics. So, in this lecture, I'll explain with some numerical examples. So here I have considered one question. A die is thrown 180 times. A die is thrown 180 times and the result is given below. So here 1, 2, 3, 4, 5, 6 is all about the appearance in the upper surface. So 1 appears 29 times, 2 appears 21 times, 3 appears 18 times, 4 appears 38 times, 5 appears 36 times, 6 appears 38 times. If I add together, it will be 180. So here it is given chi-square test. So in this problem, so just you have to solve this problem by chi-square test. What is our objective? Our objective to test it by using chi-square. The die is biased or not. That is very important. The die is biased or not. Die is biased or not. The given information is this. That is a chi-square. So here 5 indicates the degree of freedom. The 5 indicates the degree of freedom, and second one is at what level you want to test it, that is called alpha. So what is degree of freedom? Basically it is coming how many number of data you are having, that is what are the number of outcomes you are having, that is 6 number of outcomes you are having. So one less, that is n minus 1, that is degree of freedom. Okay, so this is the information. Now come to the solution. It's a very easy. So first you have to write down. So here die is thrown 180 times. Is it okay? Now EI. What is EI? That is your expected frequencies. Expected frequencies, that is 180 by n. What is n? How many number of data you have? That number of options. So here it is coming 180 by 6. If you use your calculator, it is coming 30. That is expected frequency for each and every outcomes is 30. Okay, is it clear? Is it okay? Now we want to calculate through one by one through table. It will be better for you. Okay, it is your expected frequency. Okay, now everyone please try to understand. It's very easy. First you write down that is your OI. Then you write down EI. Okay, then you write down OI minus EI. Then you write down OI minus EI whole square. Then you write down OI minus EI whole square by EI. Clear? Suppose you have a question in your mind, why you are calculating this? Why you are calculating this? Correct? So because why I am calculating? So please write down the logic. So first you have to write down what about the null hypothesis. First you write down null hypothesis. That is null hypothesis. that is H naught is equals to die is biased. Is it clear? What about the alternative hypothesis? H1 die is not biased, means not. So here null hypothesis you are considering yes, and alternate hypothesis is always reverse of that. Is it clear? Okay. Next to write down the test statistic. Test statistic. What is that? Chi square is equals to summation I is equals to 1 to n OI minus EI whole square by EI. What is EI? Expected frequency. What is OI? OI stands for observed frequency. Observe whatever you have. So in this case, what is N? N is equals to 6. So you may write I is equals to 1 to 6 OI minus EI whole square by EI. So we want to calculate this. So that's why this table is required. Is it clear to all of you? I repeat, first you write down what is your the given information, from where you need to calculate the expected frequency, total number, how many number of outcomes are coming, and how many number of variation you have, that is 180 by n. Then here you want to test it whether your die is biased or not. Correct? So here null hypothesis will be your die is biased. What about the reverse of it? Your die is not biased. Clear? So next you write down the test statistic. It is a chi-square. This is a notation. Chi-square equals to summation I is equals to 1 to n OI minus EI whole square by EI is equals to. So here n is equals to 6. So that's why I'm writing I is equals to 1 to n OI minus EI whole square by EI. Okay. If you want to find this value, you need to calculate this table. Okay. Is it clear? So now you calculate this. Always you should create this table, it will help you a lot. Okay. Okay. So here now 1 appear, 2 appear, 3 appear, 4 appear, 5 appear, 6 appear. Correct. What about your OI? OI you can write down your OI from here. Okay. So we may write 29, 21, 18, then 38, then 36 and 38. Is it clear to all of you from where it is coming? From the given point 29, 21, 18, 30, 36, 38. Okay. What is your EI? All do you know? 30, 30, 30, 30, 30, 30. Is it okay? Now, what is the difference? -1, -9, -12, 8, 6 and 8. Square it. 181, 144, 64, 36, 64. Is it clear? Now this by this, so you may write 1 by 30, 81 by 30, 144 by 30, 64 by 30, 36 by 30, 64 by 30. What is our requirement? Our requirement to find the total of it, summation of it. Okay, so how much is coming? How much is coming? Basically, so here it is coming, if I add all together, it is coming sorry 390 by 30 is equals to 13. Is it clear? That means ultimate it is coming summation I is equals to 1 to n, sorry 1 to 6, because you are having 6 OI minus EI whole square by EI is equals to is coming 1 by only 13 is coming. Clear? Is it clear? So this is your next line you may write. Is it okay? Just first you have to calculate the numerator, then denominator is same. Okay, so therefore you may write, therefore chi square is equals to summation I is equals to 1 to 6 OI minus EI whole square by EI is coming 13 is equals to chi square cal. Okay, is it clear? Is it clear? Next you write down the degree of freedom is df is equals to n minus 1. What is the number of variation? 6. 1 2 3 4 5 6. Ultimately it is coming 6 minus 1 is equals to 5. Okay, the level of significance, the level of significance is at 5%. How to decide that? It is given. Okay, 5%. So therefore you may write chi square 5 comma 0.05 is equal, this portion is given 11.07. correct? This is called chi square tab. This one is cal, this one is tab. That means this one is coming from your table, this one is coming from your table. Okay, so from here it is clear that chi square cal and chi square tab, which one is big? So from here it is clear chi square cal is big. Here it is 13 and this one is 11 point something. Okay, is it clear? Is it clear? So if chi square cal is big, is it okay? If chi square cal is big, so you may write if chi square cal is big, you may write chi square cal is equals to 13 lies in the rejected region. So therefore if chi square cal is big, automatically value in the rejected region, it is obvious. If chi square cal is less, then accepted region. Okay, please remember. Okay, so you write down, therefore null hypothesis is rejected. Okay, alternative thesis is accepted. If your ZCal is lies on the rejected region, null hypothesis will be rejected. So alternate hypothesis will be accepted. So therefore you may write, therefore, what about the null hypothesis? What about the null hypothesis? Your null hypothesis is dye is biased. And what about the alternative hypothesis? Dye is not biased. What about the result is coming? Their alternative hypothesis is accepted. So you may write down dye is not biased. Is it clear? Is it clear? Okay, thank you. Thank you very much. Please do subscribe.